A virtual network. In general, Internet software provides the appearances of a single, seamless communication system to which many computers attach. The system offers universal service. Each computer is assigned an address, and any computer can send a packet to any other computer. Furthermore, Internet Protocol software hides the details of physical network connections, physical addresses, and routing information. Neither users nor application programs are aware of the underlying physical networks or the routers that connect them. We say that an internet is a virtual network system because the communication system is an abstraction. That is, although a combination of hardware and software provides the illusion of a uniform network system, no such network exists. Figure 13.3 illustrates the virtual network concept as well as a corresponding physical structure. Basically, there are two subfigures of figure 13.3. In the first figure, actually, just a big cloud where connected with 6 different entities. And for the second subfigure within this figure, the big cloud has been illustrated, and there are several small components inside of the big cloud that including net. Like net 1, net 2, net 3, there are small clouds inside of this big cloud called net 1, net 2, and net 3, and net 4, and net 5. And also, for connecting small subnets inside of this big cloud, there are routers. So this is figure 13.3, the internet concept. Protocols for internet working. Although many protocols have been adapted for use in an internet, one suite stands out as the most widely used for internet working. The suite is formally known as the TCP/IP Internet Protocols. Most networking professionals simply refer to them as TCP/IP. TCP/IP was the first set of protocols developed for use in an internet. Indeed, researchers who devised the TCP/IP also developed the Internet architecture described earlier in this chapter. Work on TCP/IP began in the 1970s, approximately the same time that local area networks were being developed. The U.S. military funded much of the research on TCP/IP and Internet working through the Advanced Research Project Agency, ARPA. And the military was among the first organizations to have multiple physical networks. Consequently, the military was among the first to realize the need for universal service. By the mid-1980s, the National Science Foundation, NSF, and other U.S. government agencies were funding development of TCP/IP and a large internet that was used to test the protocols. Significance of Internet working and TCP/IP. Research on Internet working and TCP/IP protocols has produced dramatic results. Internet working has become one of the most important ideas in modern networking. In fact, Internet technology has revolutionized computer communication. Most large organizations already use Internet working as the primary computer communication mechanism. Smaller organizations and individuals are beginning to do as well. More important, in addition to private internets, the TCP/IP technology has made possible a global internet that reaches over 5 million computers in schools, commercial organizations, and government and military sites in more than 82 countries around the world. The worldwide demand for Internet working products has affected most companies that sell networking technologies. Competition has increased because new companies have been formed to sell the hardware and software needed for Internet working. In addition, many companies have modified their protocol designs to accommodate internetworking. In particular, most network protocols were originally designed to work with one network technology and one physical network at a time. To provide internetworking capabilities, companies have extended the designs in two ways. The protocols have been adapted to work with many network technologies, and new features have been added that allow the protocols to transfer data across an internet. Layering and TCP/IP protocols. The 7-layer reference model described in Chapter 12 was devised before Internetworking was invented. Consequently, the model does not contain a layer for Internet protocols. Furthermore, the 7-layer reference model devotes an entire layer to session protocols, which have become much less important as computer systems have changed from large time-sharing systems to private workstations. As a result, researchers who developed TCP/IP invented a new layering model. This section describes the new layering model briefly. Later chapters discuss details of the protocols found in each layer. The TCP/IP layering model, which is also called the Internet layering model or the Internet reference model, contains 5 layers as figure 13.4 illustrates. Okay, so the figure 13.4 is a demonstration of the 5 layers of the TCP/IP reference model, where layer 1 representing the physical layer, layer 2 represents the network interface layer, layer 3 represents the internet layer, and layer 4 represents the transport layer. Layer 5, the top layer, is the application layer. 4 of the layers in the TCP/IP reference model correspond to one or more layers in the ISO reference model. However, the ISO model has no internet layer. This section summarizes the purpose of each layer. Okay. Layer 1 physical. Layer 1 corresponds to basic network hardware, just as layer 1 in the ISO 7-layer reference model. Layer 2 network interface. Layer 2 protocols specify how to organize data into frames and how a computer transmits frames over a network, similar to layer 2 protocols in the ISO reference model. Layer 3 is the internet layer. Layer 3 protocols specify the format of packets sent across the internet as well as the mechanisms used to forward packets from a computer through one or more routers to a final destination. Layer 4 is the transport layer. Layer 4 protocols like Layer 4 in the ISO model specify how to ensure reliable transfer. Layer 5 is the application layer. Layer 5 corresponds to Layer 6 and 7 in the ISO model. Each Layer 5 protocol specifies how one application uses an internet. To summarize, TCP/IP protocols are organized into 5 conceptual layers. Although some layers of the TCP/IP reference model correspond to layers of the ISO reference model, the ISO layering scheme does not have a layer that corresponds to TCP/IP's internet layer.